students, now we are going to discuss in 11th standard motion in the plane chapter one important topic, that is law of parallelogram. This is one of the theorem. So it is used for to add the two different vectors. You know the law of vector addition. The same method we are going to use here. But whenever we are adding the two vectors, we follow the triangle law. Then another one, that is the law of parallelogram method. Okay. So this is not only like a theory. Okay. So which is used as the practical also, as well as it will be used in not only 11th standard, in that higher standard, like a +2 in college also. So whenever to find the magnitude of the two vectors or the angle between the two vectors, we can use the law of parallelogram theorem. Okay, maybe that is resultant force or resultant velocity and something. Okay, so here initially they give only the two vectors. Okay, in between the two vectors, its magnitude will come. So in what direction that magnitude will come, that only we are going to find out here. So the objective of this question, we are going to calculate, that is magnitude, and another one direction. Okay, so that's how to find. See that law of parallelogram theorem. So this is the theorem. It's a statement. Okay, see that if two vectors acting at a point. Okay, say for example, here one vector, it is the A vector. Then one more vector, it is the B vector. Okay, so here the angle between the two vectors is the theta. Okay, right. So if the resultant in between the two vectors, maybe in between. So that angle I have taken as there is alpha. So this is resultant value. This is angle value. Then how you know this is resultant value? Resultant value means what? You want to add, So we know already this is A vector, this is B vector. B vector making an angle theta here. So we can draw here also. You remember that? So now we can add, this is B vector, this is A vector, this is A plus B vector. You remember that? The same concept only we are going to use. That one is we are going to find magnitude, another one we are going to find that direction. So how? We'll see one by one. So please take that. If two vectors acting at a point are represented in magnitude and direction, this is very important. Generally, that magnitude I taken as that is R, that is a resultant value. Okay, and the direction, that is the angle, that is I taken as alpha. So that resultant value R, alpha value, that is the direction we are going to find between by two adjacent sides of the parallelogram as a parallelogram. Okay, then the resultant is represented by the magnitude. The resultant is represented in magnitude, and the direction is, that is a diagonal passing through the common tail of two vectors. No, this is like a statement. Okay, this is one vector, this is another one vector. By using the adjacent side, we draw the one diagonal. It's a diagonal. So the diagonal is acting as resultant value. This is the angle, that is alpha. That's all. So what is R value, what is alpha value, that only we are going to calculate in this question. Okay. So I give only the two ideas. 1, 2, 3, 3 ideas. The first, I am going to draw one diagram. From that diagram, the first idea, let's take that very big right triangle. Second one, small right triangle. Then third one, same small triangle. Let's to find angle. The fourth one, just you have to substitute. Then you can get magnitude and direction. Only the 4 steps. One is big triangle, another one is small triangle, third one angle, then fourth one substitution. That's all. Only 4 steps. It's very important questions. Please listen. Okay. See that. First see the diagram. It's a diagram. Okay. Now let's take 2 vectors. That one is P vector, another one is Q vector. So please listen. Okay. So this is P vector. Okay. It's a P vector. So watching O. This is the point A. So now I can write as OA equal to P, or OP vector equal to P vector. Okay, like that. Next, one more vector, that is Q. Okay, this is Q vector. Okay, this is the point B. So we can write as OB is equal to Q, or OP vector equal to Q vector. Now the angle between P vector and Q vector is, that is theta. Angle between P vector and Q vector is theta. Okay. Now, then how to add the 2 vectors? So you know very well the law of vector addition. This is first vector. The first vector head is connected with the second vector tail. First vector head is connected with the second vector tail. Then finally we want to add first vector tail with the second vector head. So this is, for example, this is A, this is B, means this is resultant value, that is A plus B. This is A vector, this is B vector, this is A vector plus B vector. You remember that? So we can join like this. So one tail is connected with one head, that is the rule. So now what I do? The same angle, see that now same angle. This angle is theta. So here also making angle is theta. So it applying the placement. So what will get? You can get like this. Okay. Okay. This is the A, B is there. So I mentioned the point. This is C. Like that, this OA is retraced here. Okay. Join together. That's all. Okay. Now see that first vector, second vector, we can join like this. First vector, second vector. So this is Q vector, this is also Q vector. This is P vector, this is also P vector. Now we can join here. So I can get it's a direction, resultant direction. This is resultant value. This is resultant value. Resultant direction is what? That is alpha. So this resultant value and alpha value only we are going to calculate in this question. Okay. So I hope you understand the diagram. So this dotted line, make a dot line. Now this is known as parallelogram. This is known as parallelogram. Okay, now the parallelogram is ready. Next, for derivation purpose, I have to extend. So this is Q vector. You can extend this like this because we need right triangle. So that only extended like this. So this point I taken as D. You know very well here making a 90 degree. So to produce right triangle. Clear? Right. So this is a diagram for parallelogram. Now we are going to, what is that? We are going to derive. The first one, let's take big triangle. Second one, small triangle. Third one, from small triangle, we are going to find the angles. Then fourth one, substitute. Shall we do one by one? Yes, see that. The first, please listen. First, see this derivation. see this derivation. First we know the big triangle. So from right triangle what? Big triangle. So this is OCD or COD. From COD, triangle COD. Okay. So by using the Pythagoras theorem, I can write OC squared is equal to OD squared plus CD squared. Okay. So now again OC squared is equal to OD. So you know very well this OD. See that OD is equal to, OD is nothing but what? OA plus AD. OA plus AD. So I can write, instead of this OD, I can write OA plus AD, then whole square, plus as usual, this CD square is there. Now, this is I can expand as A plus B whole square formula. We know the formula for A plus B whole square. A plus B the whole square, you can write A square plus B square plus 2AB. So like that I can write as OA square plus AD square plus 2 into OA into AD. So this OD is equal to OA plus AD square. OD square equal to OA plus AD square. Again, OA plus AD whole square I can write OA square plus AD square to OA into AD. Okay. Then plus as usual, this CD square is there. I hope you understand the steps. Okay. Right. Then next, so this is I consider as equation number 1. Okay. So this is equation number 1. Okay. I hope this is equation number 1. Next, let's see that. So big triangle model is covered. Next to small triangle. See that this is big triangle. Next see that this is small triangle. One more right triangle. So we can write from you know very well, this is the angle theta. So this is also angle theta. So this is the angle is called theta. So now I can write from the triangle CAD, from the right triangle CAD. Okay. So using the Pythagoras theorem, AC squared is equal to AD squared plus CD squared. Okay. Now this is I taken as equation number 2. Okay. Equation 1 from big triangle, equation 2 from small triangle. Now that equation 2 applied in equation number 1. Therefore, equation 1 we can write as OC squared is equal to, see that OA squared AD squared plus 2 into OA AD into CD squared. Please carefully watch that. In the equation number 2, AD squared plus CD squared. See that AD squared plus CD squared. So instead of this AD squared plus CD squared, I have to mention AC squared. Instead of AD squared plus CD squared, I can mention AC squared. Okay, we'll do one by one. First, OA squared plus AD squared plus CD squared. AC squared AC squared plus 2 into OA into AD. 2 into OA into AD. That's all. Now steps over. So this is taken as equation number 3. Okay. So equation 1 from big triangle, equation 2 on small triangle, equation 3 we have substituted. So 2 steps over. Third steps, we can find the angle from the same small triangle. So once again we can write, so from right triangle CAD. Okay, so please listen. From the right triangle CAD, so now I can write how to find. So we want to write sin theta and cos theta. Why we want to use sin theta and cos theta? So while finding the direction we know. Okay, so please listen. So advanced I find now. So sin theta. What is the formula for sin theta? Sin theta is equal to opposite divided by hypotenuse. So this is the angle. Opposite what? CD. Then hypotenuse what? AC. Okay. Sin theta is equal to AD divided by AC. Therefore, CD is equal to AC sin theta. Okay, like that, cos theta you should find. Cos theta is equal to, cos theta you know, that is adjacent divided by hypotenuse. Adjacent will be what? AD divided by hypotenuse is what? AC. Therefore, AD is equal to AC cos theta, AC into cos theta. So now the angle is ready. Okay. Now we can write the resultant value now. This angle value substitute in equation number 3. So equation number 3 becomes, we can write as OC squared equal to OA squared. See that OA is nothing but what? This is OA. Or otherwise first you submit one more step, we can write OA squared plus AC squared plus 2 into OA into AD. See that AD, this AD equal to AC cos theta. Okay, so now we can substitute OC squared. OC is nothing but what? OC is nothing but R. Therefore, R squared is equal to OA. OA is nothing but what? OA is nothing but P. That is P squared plus AC. AC is nothing but what? Q. That is Q squared plus 2 into again OA. OA is nothing but what? P. Then AC. AC means what? This AC. AC means what? That is a Q. PQ cos theta. So R squared is equal to P square plus Q square plus 2 PQ cos theta. Therefore, we can write as R is equal to, the square is moving on the other side. We can write as this is root. Okay, this is the root. I think this page is not there. Okay, I can write here. Okay, so I can mention here. So the last step, this is this is P vector, this is also P vector. So the steps I can write here. Therefore, R is equal to, square is moving that side, within root. So within the root I can write P square plus Q square plus 2 PQ cos theta. That's all. Now we found the magnitude of this question. Okay, so now the magnitude is ready. Okay, so next we are going to calculate the angle, that is the direction, that is the alpha value we are going to calculate. So it is so easy steps, the derivation, the magnitude derivation. First, big triangle, idea is what? Can you say the idea? First idea, big right triangle. Second idea, small right triangle. Third idea, to find angle, that is a theta, that is sin theta cos theta. Then the fourth one, we have to substitute, that's all. And the fourth idea, we got the resultant value. So the resultant is over. Okay. Next we are going to find, what is that? Direction, or otherwise we say there is an angle we are going to find. Okay, the resultant angle we are going to find. Okay, or the magnitude direction we are going to find. Okay. See the next one, we are going to find the angle or the direction. We are going to find the direction. It's nothing but what? It is alpha value. So you know very well here that angle. So let's take consider as right triangle. That is from a right triangle. That is big triangle. That is COD. Okay. Yes. C, O, and D. Okay. So now we can write that is tan alpha is equal to, we can write how to find the tan theta, opposite divided by adjacent. Opposite what? CD divided by adjacent what? Body. Okay, so the next step, therefore tan alpha is equal to, CD is nothing but what? CD. Okay, so already we derived, CD value, that is CD is equal to, we can write CD is equal to, that is AC sin theta divided by OD. So CD divided by OD. OD actually OA plus AD. OA plus AD. So OA is nothing but what? That is a P. Okay, otherwise you can write one more step. OA plus AD. AD is nothing but, we know that there is AD is equal to OA cos theta. OA cos theta. Sorry, AC cos theta. Q sin theta divided by P plus Q cos theta. Yes, correct only. So we can write this is AC. So we can write the next step here. I can write the next steps here. Okay. So please listen. So tan alpha. So tan alpha is equal to AC. AC is nothing but what? AC is nothing but Q. So Q sin theta divided by OA is nothing but what? OA is nothing but P. So P plus AC is nothing but what? AC is nothing but Q. Therefore Q cos theta. Okay, so therefore we can write alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. So now you know this is the direction. This is the direction or the angle in the law of parallelogram. Next case, we are going to find the special case. If the two vectors acting in the same direction means what will happen? Okay, so the two vectors, okay, it's a vector 1, vector 2. The both vectors travel in the same direction, what will happen? Or both vectors travel in opposite direction, what will happen? Or both vectors mutually perpendicular, what will happen? So like that, the four special cases we are going to discuss. Okay, so let's discuss one by one. So I am going to rub this. So please listen. So that is a special case of this question. Please listen. So the next one, the last step, that is a special case. This is a special case. Okay, so we know very well the resultant value, that is r is equal to whole root of p square plus q square plus 2pq cos theta. Then another one, alpha is equal to tan inverse of q sin theta divided by p plus q cos theta. So please remember this. So if the two vectors acting in same direction, okay, so we can write theta is equal to 0 degree. If the two vectors acting in the same direction, okay, so the angle will be the same. Okay, a vector, b vector in same direction, so there is no angle. So that is a 0 degree. So we can write as cos 0 will come. So therefore resultant value r is equal to, so I can write like this. Resultant value r is equal to whole root of p square plus q square plus 2pq cos 0 degree. So we know that cos 0 is equal to 1. Therefore r is equal to whole root of p square plus q square plus 2pq. Okay, so this is like a square plus b square plus 2ab. So we know the formula, algebra formula, that is whole root of p plus q the whole square. This is like a plus b whole square, a square plus b square plus 2ab. Therefore r is equal to, okay, square root cancel. So we can write answer is p vector plus q vector, that or p plus q. So this is, the resultant value. So we know that when the two vectors acting in the same direction, we should add the vector. That only we are going to do here. Okay. Suppose, see that angle alpha is equal to tan inverse of q sin theta. So we know that sin 0 divided by p plus q cos 0 degree. But you know very well, sin 0 value of sin 0 degree is equal to 0. So 0 divided by anything is 0. So entire value will be 0. So angle is 0. So you know very well. Okay, so p vector, q vector making some angle, some alpha is there, but it is making in the same direction. So there is no alpha. That's no resultant value. Resultant value is there, but there is no alpha value. Okay, because in the same direction. So I hope you understand that special case number 1. This is the first special case. So first special case you understood, theta is equal to what? Theta is equal to 0 degree. Like that, the next one, theta is equal to 180 degree. What happened? Listen, theta is equal to 180 degree. So theta is equal to 180 degree, we can say that. Okay, I'll explain here itself. So then now the second case, theta is equal to what? 180 degree. Okay. So 180 degree we can write as, so cos theta what will come here? 180. Okay, 180. So cos 180, cos 180 is equal to minus 1. So we can write minus 2pq. So here minus will come. Here minus will come. Now, if you observe that, okay, sorry. This is like that, a square plus b square minus 2ab. So what is the formula? A minus b whole square. So a minus b whole square. So whole root of p minus q whole square, square root will be cancelled. So that is equal to r is equal to p minus q only will come. So we know very well when the two vector, okay, the previous case is acting in same direction, but 180 means acting in opposite direction. So two vector acting in opposite direction, we can write what is the angle 180. So here sine 180 will come, sine 180 divided by cos 180. Anyhow, sine 180 also what? 0. Therefore alpha is equal to 0. Okay. So if the two vectors acting in opposite direction, the resultant value what? How to find the resultant value? So you should take subtraction of two vectors, and then angle is what? 0. So now you know in the special case, the first one, theta is equal to theta is equal to 0 degree. The resultant value is equal to P plus Q. Then alpha value is equal to 0, like that. Second case, theta is equal to 180 degree, R is equal to P minus Q. What is alpha? Alpha is equal to 0. So two special cases is over. Next one, third special case. Okay, please listen. Third special case. Third special case, the two vectors perpendicular to each other, that is 90 degree. So now I can write as here cos 90 degree. You know cos 90 is equal to 0. So this term will not come. Okay, R is equal to whole root of P square plus Q square only. Okay, so the remaining term inside, that's all. Please listen. So this is the resultant value. R is equal to P square plus Q square. So the third step, that is that theta is equal to 90 degree, R will equal to whole root of P square plus Q square. Then alpha is there, that is the angle. Angle we can write as, that is alpha is equal to tan inverse of Q sin 90 divided by P plus Q cos 90. Therefore alpha is equal to tan inverse of, tan inverse of sin 90 value is equal to 1. So the numerator only Q is there, divided by P plus Q cos theta. Cos 90 is equal to 0. So that term will not come. So this is the angle value. So tan inverse of Q by P. So that alpha value I write here. Therefore alpha is equal to tan inverse of Q divided by P. Therefore alpha is equal to tan inverse of Q by C. Okay students, I hope you understand the law of parallelogram, that statement, that derivation for magnitude and derivation for direction with the special case. It's a very easy idea. First large triangle, small triangle, angle, then finally we find the magnitude. Then last one for that is a direction by using the alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. Then different special case. If the two vector acting in same direction, angle is 0. So resultant value should be add alpha value, direction is 0, and then the angle is 0, resultant angle is 0. And then if it is two vectors acting in opposite direction, so we should subtract this two vector, then magnitude direction is 0, that means angle is 0. The last one, if the two vectors is in 90 degree, so we can write as the magnitude, that is R is equal to whole root of P square plus Q square. And the last one, its direction, if the two vectors acting perpendicular to each other, this is P vector, this is Q vector, acting perpendicular to each other. Perpendicular to each other means what? So this resultant will be here. So we should find exactly what? This like a slope will come. Okay, this like one slope. So slope means what? Q value divided by P value, that only tan inverse of Q by P. Okay students, I hope you understand the law of parallelogram theorem. Okay, if you have any doubt in between, just one more time you rewind and watch and get clear picture. Okay.